In this video, I'm going to go through some additional calculations to try to get a little bit more meaningfulness out of our skewness and kurtosis calculations out of our statistics here. And what you see here at the bottom are three additional equations. In this video, I'm going to calculate the z-score for skewness and the z-score for kurtosis. These are not the same z-scores that we see here that we had conducted in a previous video, but rather I'm going to essentially use the z-test to establish if the skewness and kurtosis values are quote-unquote statistically significant. And I'm going to do that with a two-tailed test at the 0.05 level. Now the first calculation I'm going to do here is I'm going to calculate the z-value for the skewness statistic that we had calculated in an earlier video. So I'm just going to give this the label z skew, and I'm going to put this value in this cell right here. So I'm going to hit the equal sign, and I'm just going to follow the format of our equation here, where I'm going to take the skewness value that we had calculated, our skewness statistic. I'm going to forward slash, means I'm going to divide that by the standard error of the skewness that we had calculated as well in an earlier video. So I'm going to click this and I'm going to hit enter, and I come up with a value of 1.89. Now the comparable value is 1.96, and let me just bold that here with a different color. Now the 1.96 is the critical value along the normal distribution, and the reason we use the normal distribution is because we're calculating a z-score or a z statistic. Likewise, we can do the same thing with the kurtosis value. So I'm going to do that right now. I'm going to go z kurtosis. I'm going to hit the equal sign, and I'm going to take the kurtosis statistic we had calculated earlier, and I'm going to divide that by the standard error of the kurtosis, and I get 0.37, and once again here it's the 1.96 critical value that we are going to compare our z-skew and our z-kurt values to. So what we see here in both scenarios, because the values that we had just calculated is not equal to or greater than the critical value of 1.96, then we would conclude that the skewness value and the kurtosis value are not statistically different than 0 on these two statistics, indicating that the skewness value is not significantly different than a curve that's not skewed. Likewise, with kurtosis, the statistic here of 0.36 being much less than 1.96, or rather just being less than 1.96, suggests that it's not different from a mesokurtic type of distribution. So this ends this very brief video on calculating a z-test or calculating a z-statistic for our skewness and kurtosis statistics.